So polymers. Polymers are long chain-like molecules composed of repeating units called monomers. I keep meaning to look up what is a mer. Hey Siri, what is mer?
Mer is a natural gum or resin extracted from a number of small, thorny tree species of the genus Commiphora.
That's spelled wrong.
Would you like to hear more?
No, thank you. I still need to look that up. What is a mer? A polymer is a lot of them, and a monomer is just one of them. It means something. I don't remember what it means.
It means member of a particular group.
Pardon me?
Member of a particular group.
Member of a particular group. Thank you. So a member of a particular group, you've got a lot of them, or one of them, or two of them. So they're natural polymers. There's a whole bunch of them in your body. Proteins, your DNA. And starch is a polymer. We also have synthetic polymers, PVC, styrofoam, nylon, plexiglass, plastics in general, very useful. Most polymers are very durable because the polymer is a much larger molecule, and so the intermolecular forces of attraction that hold them together are going to be stronger than with smaller molecules. You've got larger surface area. A lot of them are flexible and they can twist and tangle around each other. And so in order to tear or rip the polymer, you either have to mess up those strong intermolecular forces or you have to break covalent bonds. And so that's going to be more difficult to do than just a regular molecular compound. So one common plastic is polyethylene. It's one of the simplest. So here's our monomer. This is the member of a group. So this is ethene, or also known as ethylene. So polyethylene is just a bunch of these hooked together. Well, how do you hook these together? These carbons have octets and everybody's fine. Well, what happens is this pi bond here is broken and replaced with a bond to another carbon atom. So we got some rearranging going on, and how that happens you'll learn about in organic chemistry. But we take this monomer, this individual unit, and we connect them together, and now we have a polymer, polyethylene, because it's many ethylenes. And how long the chains are depends on how it was made. Because it's pretty much impossible to have all the chains be exactly the same length, you don't refer to different types of polyethylene as having a specific number of the ethylene units. You look more at the overall characteristics of it. But this is called an addition polymer because we're adding these things together and not losing anything. Nothing is coming out. No atoms are lost. So we can have high density polyethylene, there's low density polyethylene, and guess what? They have different densities. High density polyethylene has very little branching. So the chains are straight chains, and so they can fit together very nicely. So think of clearing out some branches in the backyard. And if you have branches, just long sticks that don't have any side branches on them, they're very easy to bundle together and get into the yard waste container, right? If you have ones that have a lot of branching, twigs and stuff on the side, it is really hard to get those to squish together, right? Because they just get all tangled up. The density is lower because they don't fit together very well. Lower density, lower strength, lower heat resistance. So high density would be used in things like milk jugs, low density in things like common plastic bags, which are becoming less common. Thank you, California. Substituted polyethylenes. So this is a whole class of polymers, polyethylenes, where we've substituted some of the hydrogens. So this is an example where every other carbon has one hydrogen that's been exchanged for a chlorine. So this is the chain or backbone, kind of like a bracelet, and this is the charms hanging off of it. So here we've got chlorine atoms. That's going to change the characteristics of the polymer. This is called polyvinyl chloride. It's formed from chloroethane or vinyl chloride, all these names. So PVC, polyvinyl chloride, useful for irrigation pipes, lots of other things. Copolymers. Copolymers contain two different kinds of monomers. Nylon is an example. When those two different monomers add together, usually there's some atoms that are eliminated. It's an elimination reaction, also known as a condensation reaction. So here, hexamethylene diamine and adipic acid combined, this oxygen and this hydroxyl group are lost as water, and a bond here is formed, and now we have a dimer, and there's the water molecule that came out. These dimers can then polymerize and form nylon. So these are called condensation polymers because they eliminate an atom or small group of atoms when they polymerize. Addition polymers do not eliminate anything. And here's a chart from your book. I'm just showing some different kinds of polymers here. Addition polymers, polyethylene. You can have polypropylene, polystyrene, polyvinyl chloride. That's the substituted version. Here are some condensation polymers, polyurethane, polyethylene terephthalate, also known as a polyester, nylon 6,6. There's lots of different kinds of nylon depending on what the different monomers are.